All right, hello again, year nines. We're going to redo this same cone question, but we're going to use a different method. So just a reminder, in the last video, we saw, okay, if I found the height of this cone, we used our length scale to then say, okay, well, the height of this cone was, I can't remember what it was, but whatever it was, we used our length scale to figure out the height then of the smaller cone. And then once we knew the height of the smaller cone, we took the volume of the cone. We said area of base times the height divided by 3 gave us the volume of that smaller cone. But there is a slightly faster method for doing this question. I think you guys can see this. The radius here is 2 meters. The radius here is 5 meters. So that tells me the length scale, it's a 2 to 5 ratio for the length scale. 2 meters over here results in 5 meters over here. And a side idea, sometimes it's a little bit weird to think 2 to 5, that's not really weird, it's kind of weird. So another way to think about this is if I divide by 2, I end up with, that means 1 meter here results in 2.5 meters over on this side. And we don't like to write our ratios with decimals, so this is not the correct way to write it, but this is the correct way to think about it. To think that, well, 1 meter here is 2.5 meters over on this side. But the question asks us for volume. We don't know the volume. What's the volume of this cone? We know the volume here is 8,000. What's the volume of this one? Well, since it's a question about volume, that's a really good indication that we should find volume scale. So we know the length scale between these two, but what is the volume scale? How many little cubic meters over here results with how many cubic meters over on this side? So we hopefully remember volume scale is you take your length scale and you cube it, because when you talk about volume, we usually say, meters cubed or centimeters cubed. So length scale is also going to be cubed. So when I cube this length scale, 2 times 2 times 2 gives me 8. And 5 times 5 is 25, times 5 again is 125. So what this means, this is my volume scale. This means 8 little cubic meters in this cone results with 125 cubic meters over in this cone. And again, for me, I'm just going to see if this works, but I don't like having an 8 to 125 to say, okay, well, if 8 cubic meters here is 125 cubic meters over here, I want to think about, well, what would just 1 cubic meter over here be equal to? So if I just had 1 cubic meter here, how many cubic meters does that equal over here? So I'm going to take my 125 and I'm going to divide it by 8 to figure out what just 1 would be. So 1 cubic meter over here results with 15.625 cubic meters on this side. And if you want to use this kind of method that I'm using, you need to keep all the decimal places. If this went on, 100 decimal places, you'd have to keep all those decimal places in your calculator so that your final answer is really accurate. Okay, now that I know this, that means every 15.625 cubic meters in this big cone gives me just 1 cubic meter over on this side. So I'm going to take my 8,000, I'm going to figure out how many 15.625s fit into my 8,000, and that will tell me how many little cubic meters I have over here. So I'm going to take 8,000 divided by 15.625. So 8,000 divided by 15.625, and that equals 512. So what that tells me is the volume of this cone over here should be approximately 512 meters cubed. So volume of small cone is 512 meters cubed. And that was a lot faster than our previous method. We get the answer a lot quicker if we do it that way. All right, hopefully that made sense. And yeah, ask me if you have questions. See you guys in the next video.